Alright guys, welcome back. We're going to be solving another question from engineering mechanics, and we have question 57, and it's desired that the person be able to begin closing the van hatch from the open position, as we can see, and she's going to put a 40 Newton force P on the end of the hatch, and we need to determine the necessary force in each of the two hydraulic struts AB. So we're going to have two hydraulic struts, one at the front and one in the back. So we are looking for the force in each of them, and the center of mass is 40 kilogram and is 37.5 millimeter directly below 0.8. So this would be where the center of mass is, and we have a note at the end that we can treat this problem as a two-dimensional question. So as always, we're going to start with the free body diagram of this part or the door. We're going to see which forces do we have. So obviously we have the force P at one end. We're going to have the weight of this, which is going to be mass times. So our weight would be M times G. Our mass is 40 kilograms. So we're going to multiply by acceleration of gravity on Earth, 9.81 meter per square second. That's going to give us the mass. We're going to have two reactions at point OX and OY since it's a hinge. And obviously we're going to have the force that is applying from the strut to the door. And we're going to show that with 2F since we are asked to find the force in each of the two hydraulic struts. So we are in equilibrium. We're going to use our equilibrium equations, and we have three unknowns in here, but we are not interested in the reaction that we have at point O. So it seems that if we just manage to find the moment of all of these forces about point O equals 0, we should be able to find all the unknowns that we have in here. So we're going to use the 2D shortcut that we discussed over and over in this channel, and for that we need to find some information about some of the angles in here. So we can see a higher magnification of the hydraulic strut in here, and this is our force 2F. And for finding the moment of this force, we should be able to find some sort of angles in here. And if we just continue this point to here, and we can call this point maybe D, we're going to create a right triangle in this figure. Let me just show that right triangle a bit better. And we also have another triangle in here, which I'm highlighting in yellow underneath, which the question is giving us all the dimensions for this triangle. So for this triangle, if we just use the law of cosine, we should be able to find this angle theta. And what law of cosine is saying is that OB squared is equal to AB squared plus AO squared minus 2AB times AO times cosine of that angle theta. So we should be able to find the cosine of theta in here. So cosine of theta would be basically AB squared plus AO squared minus OB squared divided by 2AB times AO. We just find the cosine inverse of this value in here. So let's calculate that. AB is 600, so 600 squared plus AO is 550 squared minus 2 times AB is 600 times 550 minus OB squared, which is 175 squared. And in the denominator, we have 2 times AB, which is 600 times AO 550. And one thing that I forgot, we are trying to find the cosine inverse of this value. So our angle theta would be 16.79 degrees. And we know that this angle right here is 30 degrees. So this angle is 30 degrees, which means this whole angle is 30. So if we just call this angle here maybe alpha, we know alpha plus theta is 30 degrees. So alpha would be 30 minus 16.79, which is going to give us 13.21. So now that we have alpha, finding the moment is pretty easy. So we're going to have the moment of force P, which as we can see is counterclockwise. So our moment would be, so 0 is equal to the moment of P we know our P is 40 newtons, so 40 times distance from here to O, which we know is 1125. We're gonna have the moment of the weight in here. This one's also counterclockwise, so plus 40 times 9.81. The distance would be basically the 80 that we found in here. So we call this point D, and what we are interested is this distance. We can call it 80, and for finding the 80, now that we have the alpha, it's pretty easy. It's going to be the hypotenuse of that green triangle. Let me just highlight this one in green. So the hypotenuse of that green triangle, which is 550, and 80 would be the cosine of alpha, or cosine of 13.21. And last one, we're going to have the moment of the 2f, and the distance that we are interested, as always, would be the vertical distance to the line of action, and this is the line of action of the 2f. So if we can just find this side in here, or what we have in here as this side, we're good to go to find the moment, and that's probably the trickiest part of the question. But now that we have another right triangle, which I'm highlighting maybe in blue, so this part of the right triangle that we have, we know the angle theta, and also we have the same hypotenuse 550. So finding that opposite side to angle theta is not that hard. And also the moment about point D is clockwise, so we're going to have a negative sign 2f. Distance would be 550 sine of theta, which was 16.79. And we can find f pretty easy in here. So basically I have 40 times 1125. And we don't need to do the unit conversion for the millimeter in here because they are all in millimeter, and dividing each of them by 1,000 won't make any difference in this equation. So 1125 plus 4 times 9.81 times 550 cosine of 13.21 divided by 2 times 550 sine of 16.79 degrees. Let's just calculate this, and this will be the final answer for this question. So 40 times 1125 plus 40 times 9.81 times 550 times cosine of 13.21. And in the denominator, we have 2 times 550 times sine of 16.79. And yeah, that's going to give us 802.86 newtons, and the final answer for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.